The overall goal of this procedure is to demonstrate the optical fabrication of a one-dimensional photonic crystal cavity on a tapered optical fiber with a subwavelength diameter waist.
The key point of our method is to fabricate thousands of periodic nanocraters on a nanofiber by irradiating with just a single laser pulse, and the created nanostructure eventually acts as a one-dimensional photonic crystal cavity, which may open new possibilities for nanophotonics and quantum information science.
One essential aspect of this work is that the nanofiber itself acts as a cylindrical lens and focuses the laser beam on its shadow surface. Moreover, the single-shot fabrication makes it immune to any mechanical instabilities or any other fabrication imperfections.
Demonstrating the procedure will be Jameesh Keloth, a grad student from my laboratory.
The nanofibers for the fabrication will be produced using a commercial device. The fiber is heated with an oxo-hydrogen flame from this nozzle. The fiber is drawn by motorized stages to produce a tapered section. A computer monitors the transmission through the fiber using input from a probe laser and photodiode. The nanofiber will be made from a length of single-mode optical fiber about 210 millimeters long. Producing the nanofiber will require other equipment. To start, have a fiber coating stripper, a source of methanol, and cleanroom wipes. Also, have a reservoir of acetone in which the single-mode fiber can be immersed. To prevent dust from collecting on the nanofiber,